Hi everybody, welcome back. In our last two videos, we looked at the determinant of a matrix and the adjoint of a matrix. Now in this video, we're going to be looking at the inverse of a matrix, in particular a 2 by 2 matrix. So we looked at the determinant of a 2 by 2 matrix, as well as we looked at the adjoint of a 2 by 2 matrix. Alright, the syllabus requires us to look at the determinant and the adjoint for a 2 by 2 matrix, as well as the inverse for a 2 by 2 matrix. Alright, so let's dive into it. Alright, so here's the notes that you need to get down in a book. So you can pause the video at this point and write it off. It says, given a non-singular matrix. Now, why must it be a non-singular matrix? We'll soon get to that. Given a non-singular matrix, A equal A, B, C, D, then the inverse of A, and it's denoted, meaning that the symbolism for A inverse is A with the -1 in the power, is equal to the same matrix raised to the -1 power, symbolizing that you're going to be finding the inverse of the matrix. How do you actually find the inverse of the matrix? 1 over the determinant. Remember that if we have a letter placed between two straight lines, it means that we're finding the determinant, right? In the matrix. Yeah. So it's going to be 1 over if we're finding the inverse of matrix A, then it's going to be 1 over the determinant of matrix A multiplied by the adjoint of matrix A, which would be the same as 1 over AB minus BC times the adjoint. Remember, the adjoint is when you switch the leading diagonals and you change the signs of the non-leading diagonals. So go ahead and write that off so we can actually do some examples to make it come alive. Alright, so we are given this example. To find the inverse of matrix A, which is 2, 3, 1, 5. Now, I like to write the formula before I start doing a question, to ensure it kind of helps to eliminate making certain mistakes, like certain substitution mistakes, right? It works as a guidance, so I shouldn't skip anything, provided that I write the formula correctly. So we know that the formula for finding the inverse of a matrix is gonna be, I can write right here, A inverse equal 1 over the determinant of A times adjoint A. So what do? I have to find the determinant, I have to find the adjoint, and then I find the product, or I calculate the product, right? So I'm going to start here. I'm going to use my imply sign. The determinant of A is going to be leading diagonal, so 2 times 5 minus non-leading, 3 times 1. And that gives me 10 minus 3, which is 7. So the determinant is complete. Then find adjoint A. Adjoint A is simply switching the leading and changing the signs of the non-leading. So I have found adjoint A, and the formula says it's 1 over determinant times adjoint A. So I can put implies that here and say it's going to be 1 over 7, because that is the 7 is the determinant and it's 1 over the determinant as a fraction. So 1 over 7 multiplied by 5, -3, -1, 2. Now this is scalar multiplication. If you don't realize, when you multiply a matrix or all the elements in a matrix by a singular number, in this case the number is a fraction, right? So we're going to multiply 1/7 by 5 by each element in the matrix. Once you're multiplying by a fraction, once you're multiplying whole numbers by a fraction where 1 is the numerator, ultimately you're actually going to be replacing that 1 with those whole numbers. So this is going to be 1/7 times 5 will give us 5/7. And just in case you're wondering, why, let me show you. 1/7 multiplied by 5, which is the same as 5/1. You're going to end up with 5 times 1, 5, 7 times 1, 7. So it would give you the 5/7. So that's how we know for sure, right? So it's going to be 5/7, -3/7, -1/7, and 2/7. And that is the inverse of matrix A. We end up with a lot of fractions. And most times it's best to keep it as a fraction, right? I know a lot of persons don't like with the fractions, but leave it as the fractions that they are. And the question is complete. So we are going to look at another question. So you can pause the video and write out this example before you move on to the next question. Don't be lazy, right? Don't be lazy. Alright, so I trust that you were not lazy and you wrote off the previous example. So let's look at this example. Given the matrix B, elements -4, 5, 1, -2, we are finding B inverse. So no, B inverse is going to be 1 over the determinant of B times adjoint B, right? You don't have to do it broken up as I did in the previous example. We know that the determinant of B is going to be the product of the leading minus the product of the non-leading. So we can actually just keep this line going. So 1 over -4 times 5 minus 5 times 1. So that's AB minus BC. We get a straight line, at least one line, not pieces. Right, so that's 1 over the determinant times adjoint. And adjoint is when you switch the leading, interchange the leading elements, so -2 goes your -4 was, etc. And change the sign of the non-leading. And then you can simplify in the next line. So -4 times 5 alright, so that can't be right, right? So it's -4 times -2. I don't know how I got the 5 right there. So of course that reminds us that we have to pay attention to what we're writing, what we're doing. Look out for errors. So it's the product of the leading, so that's -4 times -2, minus the product of the non-leading, so that's 5 times 1. So 4 times 2, 8, same sign, so it's going to be positive. So that's 8 minus 5, that's 3. So we're going to have 1/3 here. And that was our adjoint. So it's 1/3 times this. And we simplify. And again, once you're multiplying by once you're multiplying whole numbers by a fraction where the numerator is 1, ultimately those whole numbers will actually become the numerator, right? So this is gonna become ultimately -2/3 -1/3, -5/3, and -4/3. And you don't need to change it into decimal. I suggest that you leave it right there. Most times that you find the adjoint, not all, but just most times, you'll end up getting, most times you find the inverse, you'll end up getting fractions. But it's not all the time, it's just most of the time, alright? So that's example 2. Because I don't want this video to be any longer, you will do example 3 on your own. I'm going to write it on the screen and you're going to try it. Alright, so there's example 3, which is actually your question. So try it and confirm with your teacher the answer. Yeah. And then guess what? Go and make up some questions of your own and do them. Practice, practice, practice to cement in the concept. Bye-bye.